So now we know that trees are great candidates for boosting as well if you are using gradient boosting, right, but trees are great candidates for bagging as well, right. So what is the important property in bagging that we talked about? What does bagging help us do? Reduce variance. Reduce variance, right. So bagging allows us to reduce variance, and in fact you can show that the reduction in variance is highest if the classifiers that you are building, okay, are not correlated, right. So I am building many classifiers and the classifiers are predicting the same output, right. So if the classifier parameters that I am estimating are somehow, if I can make them uncorrelated, right, then the reduction in variance is maximum. Kind of intuitive, right. If the classifiers are very correlated, then there is no point, they are not really different classifiers, right, they are going to give me the same output, so the variance will be high. So if I can somehow make the classifiers uncorrelated, then the reduction in variance is high, right. So there is actually a very specific relation between the amount of correlation between the classifiers and the and how much you pay in terms of the reduction in variance, right. So I am not going to derive that, I am just pointing it out to you. So if you want, you can look it up, it is there in ESL, right. And if you think about what we are doing with bagging, right, you are taking one data set, right, and you are sampling with replacement from that, right. So the probability of the trees that you are generating being correlated is rather high, right. The probability of the trees that you are generating being correlated is rather high. So can we come up with some way in which we can reduce the correlation between the trees that you are constructing, right. So I am going to be doing bagging, right. But the goal is to reduce correlation between trees, right. So the people who came up with random forest had a very simple idea for doing this, right. You start doing bagging as you would normally do, okay. So you have your data set, then you create a bag by sampling with replacement from that data, and now when you start building the tree on this data set, so what you do is at every node, right, sample some p features from your feature set. We use p for the regular feature description, right. So let me use a different. So you have total of p features, right. Your data points come from some RP space. You randomly sample some t features from that p features, okay. Find out which is the best split point, which is the best split variable among these t features alone. Split the data, go down to each of the subsets, repeat the same process, sample another t variables, right, not necessarily disjoint, right, I am just sample again, okay, sample again t more variables, okay, and then try to find out which is the best split point among these t variables and keep doing this. So what does this get us? See, if you had actually worked with the same data set, right, which I mean if you had just done bagging at the root level, it is highly likely that each one of the bagged trees would have picked the same attribute, right, just because you have subsampled it again, right. So it does not mean that the very predictive attributes will get discarded. So at the higher levels of the trees it will look very similar, right, but now you are getting rid of that. I said okay, you choose, I have chosen randomly, I have chosen t variables and only from them I am choosing the best variable, therefore I am reducing the chances that the trees will look similar, and in fact we can show that this leads to significant reduction in the variance in the bagged estimate, and random forests end up performing very well. In fact random forests are competitive with gradient boosted trees in some applications and vice versa, right. So, boosted trees are better than random forests in some applications, and random forests are better than boosted trees in some applications. And because till some time back there are very efficient random forest libraries, and people use random forests a lot, right, but now there are also very nice libraries available for gradient boosted decision trees, and therefore try everything and see which works, right.